All right, guys, so today's the last day review before CBA 4. So it's tomorrow on Tuesday, Valentine's Day. So let's go over some of our concepts. So number 1 on your review is about probability. So there's 10 students in Mrs. Relaford's second period class. Students are represented in the diagrams below by the numbers 1 through 10. If each student needs a partner for an upcoming activity, which tree diagram shows all possible combinations of students in Miss Relaford's class? Okay, so let's say that, I don't know, Jaden's in Miss Relaford's second period class, and he's the first person to choose a partner, right? So Jaden can pick any of the students in class. He can choose Braven, he can choose Sammy, he can choose Nicholas, he can choose Sophia, he can choose whoever he wants out of the 10 students, right? So he has his pick. And then after that, him and his partner are out of the conversation, right? He has a partner, and then let's see, maybe he didn't choose Braven, and Braven gets to choose. And Braven can still choose Sammy or Nick or Sophia, right? But can he choose Jaden? No, well, Jaden already has a partner, right? Okay, so knowing that, thinking that through, let's look at our answer choices. So 1, 2, 2, 3. Well, in this situation, 2 is partners with 1. Can they have another partner? No, right? Because each student needs a partner. All right. So here I have 1. So that's representing, let's say, Jaden. And then 2, 3, 4, 5. Okay, so that represents Jaden and his partners. But what about all the other combinations, right? It says show all possible combinations of students. So that's only showing Jaden and his partner. All right, let's keep looking. So then we have C and D, because I don't think it's A or B, right? Okay, C and D. So C says 1 can be partners with 2, 3, 4, 5 through 10. 2 can be partners with 3, 4, 5. Okay, I'm liking the looks of that. That looks like how we started over here, right? Over here, it has 1 can be partners with 2, 3, 4, 5, 6. Well, there weren't any exclusions, right? What about all the other kids in the class? So our answer here is going to be C. Okay, going down to number 2, it says Bailey rolls a number cube numbered 1 through 6 and flips a fair coin. Below list, which below is a list of all possible outcomes if the coin lands on heads. Okay, so let's think about this. So she's rolling a number cube, right? So when she rolls a number cube, she can get 1, 2, 3, 4, 5, or 6. And then she's flipping a fair coin. So then she can get heads or tails. Heads, tails. Heads, tails, heads, tails, heads, tails, heads, tails. Okay, but they want us to list all the possible outcomes if the coin lands on heads, right? So heads, 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 and heads. So I know she can have 1 in heads, 2 in heads, 3 in heads, 4 in heads, 5 in heads, 6 in heads. All right, so let's look. This one's tricky, huh? Okay, so 1 heads, 1 tails. 2 heads, 2 tails. Okay, well, that's all the possible outcomes, but it says, which is a list of all possible outcomes if the coin lands on heads. Okay, so we aren't interested in any tails situations, so those need to be eliminated. This one says 1, 2, 3, 4, 5, 6, and all heads. This one says just 1, 2, and 3. All right, so I would say that C matches the diagrams that we drew. Okay, the third one is talking about tables. So the table below shows, sorry, it says shoes, should be shows the orders of the last 50 customers at Magic Muffin Bake Shop. Let me fix that. And my handwriting's horrible, sorry. Okay, anyways, so based on the table above, all right, based on the table above, what is the most reasonable prediction the next customer that walks in will order a bran muffin? Okay, so right here, we read prediction. Prediction means proportion, right? So we know that we're going to put our probability on the left side, and we're always going to put X over our new total. Okay, but in this situation, they just want to know the next customer. So there's no new total. We're really just looking for the probability. So the next customer will order a bran muffin. So we're going to be focused right here on the number 8. We know that we always put what we want on the top. So the 8 is going to go on the top. And then on the bottom always is our total. Well, we can total it there, or it says 50 customers here, so we don't even have to do that. But all of our answer choices are in percent. So yes, we actually can set up a proportion, right? And to change it into a percent, we always need to put X over 100. So you can either do your cross product, or you can think about, I know 50 times 2 gets me to 100. So what you do to the bottom, you do to the top. Okay, so next, Jennifer's sewing bag contains the following colors of thread. Jennifer's going to randomly select a spool of thread. She will replace it and randomly select another. What's the probability that both spools will be blue? So we're looking for the probability of blue. So we're going to go ahead and do the probability of blue. So 6 blue, always what we want goes on top, over our total. So 6, 7, 8, 8 plus 5, or whoa, crazy. Sorry, 8 plus 7 is 15. And then we can always simplify it, right? So 6 over 15, I'm going to divide by 3. Can get 2 over 5. So that's the probability of 1 blue, but we want to know the probability that both are blue. So we want the probability of 2 blue, right? So to do a compound event, what do we do with the two probabilities? You multiply them. Excellent. Nice job. So go ahead and do that and find the right answer. Don't get fooled. Don't accidentally add. All right, next one. Spinner has 7 congruent sections numbered 1 through 7. That means they're equal in size. Congruent means equal in size, so they all have the same probability. What is the probability of spinning a number that is not greater than 4? Okay, so not greater than 4. So I'm looking for the probability of less than or equal to 4, right? Not greater than 4. So is 1 not greater than, right? 2 is not greater than, 3 is not greater than, and 4 is not greater than. So I'm not interested in 5 because that's bigger than 4, 6, and 7. Okay, so there's 1, 2, 3, 4 out of a total of how many sections? 7 sections. That's it. Next one, Jason works at a party store. The balloon in that holds their multicolored balloons contains the following colors. Jason selects a balloon at random. Which of the following statements is most accurate? So you're looking for which one's true. So the balloon is more likely to be red than all other colors combined. So more likely to be red. So 14 are red than all the other colors combined. So 7 plus 10 is 17 plus 5 is 22. So we're saying 14 is bigger than 22? Not quite. Probability of selecting a blue is greater than yellow or orange combined. So blue is 10. Is that bigger than yellow or orange combined? So 7 and 5 is 12. The next one says orange is the least likely to be selected. And then it is twice as likely to be yellow as it is to be red. So they're saying yellow is 2 times red, right? 2 times 14. Not quite. All right, so these two are linear relationship problems, okay? So when we're looking at linear relationships, the first thing you want to do is look at your y-intercept. So here is where the line crosses the y-axis, right? So it's the value of y when x is 0. So 0, 1. And we know in y equals mx plus b, right? B is the y-intercept. So value of y when x is 0. And then m is the rate of change. So change in y over change in x. Okay, so first the y-intercept. I know that in this situation it's going to say plus 1, right? So I can go ahead and eliminate b because that says minus 1, and then d does not have anything. So that's essentially saying plus 0. Okay, next step is to look that it is going uphill from left to right, right? So this is going uphill. And what did we talk about? If it's uphill, it has a positive rate of change. So here I have a negative, so I know that's not true. Here is just a positive. So remember all that we said, right? So if it's a positive m, a positive rate of change, it's uphill. If it's a negative rate of change, it's downhill when you're looking from left to right. Okay, next one. Which of the following equations best represents this graph? So yet again, we want to go ahead and look at our y-intercept. First thing we want to do to rule out anything. So we know it's value of y when x is 0, so 0, 3. That's a positive 3, so I'm going to go through and see, okay, this is plus 0.45 or 4.5. Can't be that. This says plus 3. That looks good. Plus 3. This says minus 3. Okay. And then the next step is that it's going downhill from left to right. So if it's going downhill, we know that it has to have a negative rate of change.
Can I see?
Yep, you can see.